talk about how to go from something in polar form to rectangular form. Maybe a polar point to a rectangular point, or a rectangular point to a polar point, or a rectangular equation to a polar equation. First off, let's go back to all these equations I gave you a second ago. And everything that's polar is highlighted pink. So this r comma theta, that's the polar coordinate. It's the polar point. Whereas the rectangular is in yellow, x comma y. If I look at these two formulas, the polar is in pink, r cosine theta, r sine theta. Rectangular is in yellow, x and y. So this is a relationship between the polar and the rectangular. And we can use those formulas to convert back and forth. For these two formulas, tan theta is polar, y over x is rectangular. For this, theta equals theta is polar. Over here, the r squared and the r are polar, and the x and the y's are rectangular. So every time you see a r or a theta, it's polar. Every time you see an x or a y, it's rectangular. Rectangular means like when you graph a line or a parabola. Yeah, that's rectangular. Polar is when you graph a unit circle of different radii. Okay, let's go. Let's say I give you the polar point, 3 comma pi over 3, and I want the rectangular. So this polar, 3 comma pi over 3, is r comma theta. So r comma theta. And we want the rectangular, x comma y. So let's see if there's a formula on here that says x equals y equals, because that's what we want, x and y. X equals y equals no. X equals y equals no. X equals y equals no. X equals y equals yes. So let me write down these. X equals r cosine theta. And then y equals r sine theta. Okay, now to find the x and the y, we just plug in r and theta. R is 3, theta is pi over 3. So let's go. X is equal to 3 cosine pi over 3. Y is equal to 3 sine pi over 3. And then now we look on our unit circle. Cosine is the x value of pi over 3. So here's pi over 3. The x value is 1/2. And in a second, the y value is square root of 3 over 2. So we just said the x value was 1/2. So I say x equals 3 times 1/2. And that gives me 3 over 1. 3 times 1 is 3. 1 times 2 is 2. 3 over 2. Let's look at this. Y equals 3, and I said the sine of pi over 3 was square root of 3 over 2. So that means 3 square root of 3 over 2. So the whole point was to get x comma y. Well, we just found our x. It was 3 over 2. We found our y, 3 square root 3 over 2. Hey, baby. These two represent the exact same spots on a graph, only 3 pi over 3 is in polar, like on one of these ringy things, and 3 over 2 comma 3 square root 3 over 2. That's like on an XY plane, but they still land in the same spot. Okay, let's look at this. It says if you're given rectangular 5 comma negative 5, and remember rectangular is XY, and we want polar, that's r comma theta. So let's see if there's a formula that says r equals or theta equals. R equals. Theta equals. Okay, we definitely need that. So let me write that down. Theta equals tan inverse y over x. So that'll take care of my theta. Let's see if there's a r equals. Hot darn, r equals. So let me write that sucker down. R equals square root x squared plus y squared. Okay, now let's plug in our goodies. Here we're going to have theta equals tan inverse y divided by x. Well, my y is -5, my x is 5. That means theta equals tan inverse of -1. Okay, then you look on your unit circle, and remember, tangent is y over x. So when is y divided by your x -1? Well, the points have to be the same, but one has to be a different sign. So either 3 pi over 4, points are the same, one's a different sign. Or 7 pi over 4, points are the same, one has a different sign. So let me write down both the possibilities. Theta equals 3 pi over 4 or 7 pi over 4. Okay, we're going to decide which one this is right now. On a rectangular coordinate plane, my point is 5, -5. Let's see what quadrant that's in. 5, -5. That's like 5 to the right. 1, 2, 3, 4, 5. Down 5. 1, 2, 3, 4, 5. So we're in quadrant 4 for this 5, -5. Well, this rectangular point and this polar point are supposed to be in the same spot, just represented differently. So which one of these thetas is in this fourth quadrant? Is it 3 pi over 4? No, that's in quadrant 2. 7 pi over 4, that's in quadrant 4, so that's the one we use. So goodbye, 3 pi over 4. Now let's find r. R is equal to square root of x, 5 squared, plus y squared, -5 squared. That makes 25 plus 25, then square root 50. Okay, now break it. That's like 25, 2. The 5 comes out, so r is 5 square root 2. Okay, the question was, what are the polar coordinates, r comma theta? Well, we just found r, 5 square root 2. We just found theta, 7 pi over 4. Hot darn, woo! Let's do another one. This is equations. It says the rectangular equation is x squared plus y squared equals 81. What is the polar? So, we want this x and y to disappear and instead have letters that polar coordinates have. Remember, polar has r's and thetas instead of x's and y's. So we want r's and or thetas. Sometimes we have both, sometimes we only have r, sometimes we only have theta. Okay, well, let's see if maybe there's an equation for x squared plus y squared. Maybe x squared plus y squared is equal to like r or theta. Let's see. X squared plus y squared is equal to r squared. Well, we want r, so that's close enough. So instead of this x squared plus y squared, I'm going to replace it with r squared. R squared. Again, because it's kind of like an identity. I see x squared plus y squared, and I'm going to replace it with this r squared because they're equal. And then the 81 just stays. And we want naked r, not r squared or r cubed or any of that. So let's square root it. And you get r equals 9. Woo, woo, woo. Yee. Why don't we do another one? I think we have some time. Let's say we have the rectangular equation x squared equals 19y. And we want polar. And remember, polar is, we want the letter r and or theta. That's a slash. So maybe we just have r, like the last problem, or maybe we have a r and a theta. We'll have to see. Well, first, Let's see if there's anything I can plug in for x squared. Not really. This has a y squared on it. Darn. No, that has the weird... Ugh. Okay, hey, maybe I can do this. Instead of x, I could put r cosine theta. Well, let's try that. Instead of x, I can put r cosine theta. But it's squared. So let's put a squared up here. Equals, let's see if I can replace this y with something. So let's see if I have a y equals anywhere. Y equals, y equals, y equals, y. Hot darn, y equals r sine theta. So I'm going to put r sine theta where the letter y is. Okay, now we're just going to clean it up. This extra theta is like, okay, there we go. Okay, so let's clean it up. If I square r, I get r squared. If I square cosine, I get cosine squared theta equals, if I multiply all this hooey out, I get 19 r sine theta. And just like on the last problem, we wanted it to be r equals, we're going to do the same thing here. So I'm going to try and get this r by itself. And since it's multiplying with cosine, I'm going to divide by cosine squared because I'm trying to get r by itself. Yes, I know I have an r over here. I'll get to it. Okay. So now I have r squared equals 19r sine theta over cosine squared theta. Okay. And I want r by itself. So to get rid of this r over here on the right, that's multiplying, because I need r, all my r's on the same side, and they're on two different sides. So to get rid of this r that's multiplying, I'm gonna divide by r, and it'll cancel out on the right. Well, if I divide by r over here on the left, it still kind of cancels. The r on the bottom and the squared cancel. So you get r equals 19, no more r on the top, sine theta over cosine squared theta. Hey, that's the polar equation.